Okay, this is 8-4. Again, we're doing it out of order. Simplify radical expressions. Today's the 8th. All right, simplify. And as I stated earlier, this first part of the lesson is review. Square root of 24. Is that something we've done before? Yeah. Yes. Who can tell me, who can raise their hand and how we start this off? Raise your hand. Anyone willing to share? If not, I'll call on one of you. Japheth. Sorry, I didn't see it quick enough. Japheth, what do we do? The little branch thing. You're correct. Yeah. All right. He said do the little branch thing, the factor tree. Okay, so prime factors. 24 breaks down to what and what? 6 and 4. My last class said 8 and 3. Would that work? Yeah. Okay. 4 is 2 and 2. Please stop the talking. And 6 is 2 and 3. And then we write them in 1, 2, 2, 2, and a 3. Do we all agree? Yep. All right, pairs. We take out pairs. So we circle how many at a time? 2. Does anybody know why we circle 2 at a time? It's important to today's lesson. What is this called here besides a radical? It's called the square root. Square, when you square something, there's a 2. There's a little 2 in here. We never write it. You don't have to write it right now. We never write it, but it is there. It's just like x to the first power. Do we write the first power, or do we typically just call it x? X. Same thing with the square root. We say square root, but we don't put the 2 there. Whenever it's not there, it's assumed to be there. All right, so we circle in chunks of 2. This comes out as a 2. Put it small on top. 2 root or square root, what stays in? 2 times 3 is 6. 2 square root 6 is the final answer. Okay, number 2. Square root of 60 x to the third y. Have we seen it with variables before? No. I don't believe we have, at least not in this class. Okay, 60 breaks down. We still treat the 60 the same way. I will call on Andrew. Give me 2 numbers you can use for 60. 10 and 6. Did anybody start it before him and use 30 and 2? And that is okay. We shouldn't end up in the same place. 2 and 3. 2 and 5. Square root of 2, 2, 3, 5. Those of you that used 30 and 2, did you still end up with 2, 2, 3, 5? Yes. Okay. Now, you learned this back in middle school, or maybe, no, even elementary school, maybe 6th grade, 5th, 6th grade. X to the third means x times how many x's altogether? X times x times x. You add the exponents, and 1 plus 1 plus 1 is 3. Do you agree? And y to the first power is just how many y's? 1. Okay, and we're going to do the same thing we did before. We're going to circle our pairs because this is a square root. Okay, so a 2 comes out. Does a 3 and the 5 come out? No. Does at least one set of x's come out? Does another x come out? What about a y? No, these 2 are not pairs. One's an x, one's a y. They have to be exactly the same. So what comes out? 2 times x, so we call that 2x, times the square root of 3 times 5 times y, 15. Thank you, I forgot to say the x. 3 times 5 times x times y is 15xy. So 2x times the square root of 15xy is your final beautiful answer. Yay. That's a lot of work? No? It is. It is not. The only new thing for this part, there's more new problems, but the only new part here is the variables. Everything else stays the same. And even with the variables, the pattern is still the same. Circling your pairs. Okay. Are you guys okay if we just get right into one of the harder problems? Since all this is review. Okay. 12 square root of 21a to the second b to the fifth times the square root of 56, a to the third, b to the third. Okay, a lot going on. Again, we've seen these before, just not with variables, so I do want to address. Okay, again, put your phones away. I do not want to have to tell you over and over to put them away, so don't have them on your laps because they're just going to distract you. All right, we multiply our coefficients. What's the number in front of that radical there that we cannot see? 1. We don't see it, we don't write it, but we know there's a 1 here. So what's 12 times 1? 12. Square root of. I only multiply these two numbers together to see if it's a perfect squared. It's a big number, but can you plug it in your calculator now? 21 times 56. 1,117? Oh, 76. Thank you. 1,176. All right. You learned, again, back in middle school, when you have a squared times a to the third, I heard somebody say it over there. What is it? You add the what? What are these called? You add the exponent, so it equals a to the fifth. Please stop the talking. Do you guys agree with that? Okay, so a squared times a cubed is what again? A to the fifth. Without writing it down over here, what's b to the fifth times b to the third? B to the eighth. When you are multiplying like bases, you add the exponents. When you're multiplying like bases, you add the exponents. The a stays a, the b stays b. 2 plus 3 is 5. 5 plus 3 is 8. Thank you. I heard some of you saying it. Yes? Okay. Are we good? All right. We're going to do the same thing now. Oh, before we break this down, just do a quick check to see if it's a perfect squared. Do you guys know? Some of you checked it already? Okay. So how do you do it? 1176. And what key do you hit next? Square root. Is it a perfect squared? No. I'm going to pause here and ask, how many of you guys are using your own scientific calculators? Okay, which are okay in class and doing work, but I will tell you this, you can't use them on the test. They will be these type of calculators only for the test. So, how many of you have a nice calculator and know how to use your radical keys where it does all this work for you? Some of you know how to do it. Can you use it on the test? No. So if you are not breaking them down in homework, you're not going to receive credit. Not only that, you're not going to get the practice needed for the test because you cannot use your own calculator on test day. Jaden, can you please take your hood off? Thank you. All right. So since 1176 is not a perfect square, break it down. But guys, use the numbers they originally gave us. What does it break down into? 21 and 56. 21 is 7 and 3. 56 is 8 and 7. And 8 is 4 and 2. And 4 is 2 and 2. All right. Square root. Let's see, how many 2's do I have? 3. How many 3's? And how many 7's? 2? 2 7's? Okay. How many A's? A to the fifth means how many A's? 1, 2, 3, 4, 5. And B to the eighth means how many B's? 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. The number here is called the index. We don't see it, but what little number, don't say 1. What little number's right here? A 2. It's a square root, which means we circle in chunks of 2. A set of 2's are coming out. Any other 2's? What about 3's?
No.
A set of 7's?
Yeah.
One set of A's, another set of A's. Do I have enough for all the A's to come out, or is there one left over? Okay, what about the B's? Let's see. Do they all come out? None left over. How many sets come out? 1, 2, 3, 4. All right. I want you guys thinking. Why is it, looking at the original exponents, this is a 5 and that is an 8. Without saying it out loud, think about why with the A variables we have one A left over, and why with the B variables we have no B's left over on the inside. All the pairs came out. Don't say that loud, just think about it. Why with the A's do I have not enough to make another pair, but with the B's, everything came out as a pair, no leftovers? Okay, who's willing to share? Yes? This one is even and this one is odd. Is that what you guys were thinking? Okay, so if it's even, are you going to have enough to circle all of them? If it's odd, there's always going to be how many left over? One. All right, questions? Okay, let's multiply all this together. Oh, I forgot my 12 there. What's 12 times 2? 24. Guys, let's get back to this problem, please. Okay, the 12, I didn't write there, but there is a 12 there, so I just put it back in. What's 12 times 2? 24 times 7. Can you guys calculate that? 20. What is it? 168. Okay, what else comes out? A times A squared. B times B times B times B. B to the 4th. Square root. Okay, does everyone see where the 168 is coming from? 12 times 2 times 7. A times A is A squared. B times B times B times B is B to the 4th. What's left inside? 6A. Do you guys agree? Yeah. All right, so questions on that one? Is that something you can handle on your own?
Yeah.
All right. It's what? It's a lot of work. Okay, number 4. It may be a lot of work, but it's not hard work. Do you guys agree? It's just using your calculator, breaking numbers down, finding your pairs, and you're good. Okay, number 4. The cube root of 216, a to the 9th, b to the 7th, c to the 5th. The cube root of 216, a to the 9th, b to the 7th, c to the 5th. What?
Is that all?
Is that all? Yes. How is this different from the last 3 problems? Okay, cube root. I said it differently and I wrote it differently. What did I call that number earlier? Started with an I. Index. It's the index. Okay, so earlier when it's not written in like numbers 1, 2, and 3, there's no number there. It's automatically a what? A 2. If they put a number there, then you'd say cube root or 4th root or 5th root, depending on how big that number is. How do you think that changes the problem? The amount of numbers we circle are going to be what this time? We're going to be circling, instead of chunks of 2, we're going to circle chunks of 3. So that whole even odd business is not going to work for this one, unfortunately. But there is other tools, other tricks you can use, other shortcuts. All right, we're still going to break it down the same way. It's even, I'm just going to use 2. 2 times what is 216? 108 times 2. And that's even. 2 times what is 108? 54 is even. 2 times what is 54? 27 is not even. What times what is 27? 3 and 9? And 9 is 3 and 3. Okay. Cube root of, how many 2's do I have? 3. How many 3's do I have? And how many A's do I have? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many B's do I have? 7. 1, 2, 3, 4, 5, 6, 7. And how many C's? 1, 2, 3, 4, 5. Some of you will learn shortcuts eventually where you don't have to list them all out. I like to list them out in the beginning because it's new, it's different, but once you get the hang of it and you figure out shortcuts, you may not have to expand them all out like that eventually. Okay, now because of that 3, we're circling in chunks of what? 3. So do all the 2's come out?
Yep.
As one chunk of just a 2. What about the 3's? 1 3 comes out. Are there any 2's or any 3's left over? No. Okay. Let's see the A's. Do all sets come out? Now, what was it raised to? 8 to the 9th? It's odd. Why do you think they still all came out? Because 9 divides by 3 with no remainder? Okay, so what is that? A. All right, B's. Do they all come out? 2 sets, and how many left over? 1. Why do all of them not come out? Does 7 divide by 3 evenly? No. Okay, so B times B with 1 left inside. And the C's, how many sets? Just 1 set. And how many left over? Why can't I circle that if that's a 2? It's not a square root, it's a cube root, which means I circle 3 at a time. All right, let's work this out. What's 2 times 3? 6. Anything else? Let's see. A times A is A to the 3rd. B times B is B to the 2nd. And C times nothing at all is just C. Cube root. There's no 2's, no 3's, no A's left over. What's left over? B and C squared because there's 2 of them. Do you agree? Okay. Any questions? Okay. I will tell you this. If you did all this beautiful work on a test, I would mark it wrong. Does anybody know why? One small little thing I'm forgetting. The 3. If I don't put a 3 there, it's assumed to be a what? Square root. And is this a square root? No. So you cannot forget the 3. The reason I point that out is because we're so used to not writing it, you do all that work and you forget it and then it's wrong. So be careful. If it's a cube root, a 4th root, a 5th root, you have to put that number in. Otherwise, it is wrong. Got it? Okay, the only time you won't have to do it is if everything came out. If everything came out and there was nothing left, your answer would look something like that with no radical. Okay, questions on these problems? Okay, number 5. I'm going to move on to the new types of problems. Are you guys okay with that? A versus B. 2 different types of problems. Root 5 times root 5 is problem A. Problem B is root 5 plus root 5. Is there a difference?
Yeah.
What's similar about the 2? They both have root 5s. They both have 2 root 5s. What's different? Plus and what? Multiply? All right. Should we get the same answer?
No.
Is 5 times 5 the same as 5 plus 5?
No.
No. So this is not going to come up the same either. Part A is review from last semester. Without saying 25, without using 25, without writing it or even plugging it in your calculator, what's root 5 times root 5? 5, because it is a pair. Do you guys remember that from last semester? Okay. Now, this you treat like terms. What numbers are here in the front? 1. I'm going to cover this. What in your head, what is 1x plus 1x? 2x. Not x squared, but 2x. Do you agree? 1x plus 1x is 2x. So what's 1 root 5 plus 1 root 5? 2 root 5. The root 5 stays as it is. Think about it when you're little and they start with 1 apple plus 1 apple is 2 apples. Well, 1 root 5 plus 2 root 5, that means you have 2 of the root 5s. Make sense? Okay. Number 6. Root 3 plus 7 root 3. What's the coefficient here that I don't see? 1. And remember, in order to add, these 2 numbers in here have to be the same. And then you add the coefficients. What's 1 plus 7?
8.
And the root 3 stays the same. Think of it as 1 apple plus 7 apples is 8 apples. 1 root 3 plus 7 root 3 means you have 8 of the root 3s. Got it? All right. 7. 5 root 7 plus root 63. Can I add those together and call that what? 6 root 70? Can I do that?
No.
Why am I not allowed to add those together? Yes.
Because the roots have to be the same.
The roots have to be the same. They have to be like terms. Any thoughts? There is something we can do here. Yes.
We can break it down.
Break down which one?
63.
63. Good job. Do that now. Break down your 63 and see what you end up with. What goes into 63? I heard 7 and 9. What goes into 9? Is that going to be a pair? 5 root 7 plus what? 3 root 7. They're like terms. Are they like terms now? What's the final answer? Good job. Don't forget the radical stays the same. 5 of the root 7s plus 3 of the root 7 means you have 8 of the root 7s. Got it? All right. Parentheses, -8 plus 4 root 3, close parentheses, minus parentheses, 5 plus 6 root 3. This is different. We haven't seen these type of problems before. These parentheses here, does that mean I'm going to multiply these two?
No.
No. What are we going to do with that minus sign?
Add.
Thank you. What should we do with this negative sign? Distribute the negative sign. Thank you. Okay, so I have -8 plus 4 root 3, take away 5, plus 6 root 3, or take away 6 root 3? Take away 6 root 3. -5, -6 root 3. Do you guys see how that works? Okay, and then you combine like terms, just like you would in a regular problem. What's -8's like term? -5. So you add them together. What's -8 plus -5? -13. Kids will say, oh, 2 negatives make a positive. Not when you're adding. When you're multiplying, yes. -8 plus -5 is -13. What's 4 root 3's like term? What's +4 plus -6? -2 root 3. Are these two like terms? No. So this is your final answer. Got it?
Sentence Taurus?
Mm-hmm.
Is there ever a time 13 is related to another number?
Like what?
Like if you're trying to relate it to being the multiple, like you can multiply something to get 13 or divide something to get 13. Wait, 26. Never mind.
Okay.
I just thought it was an impossible number.
Okay, it's okay. All right, guys, paying attention here. If, a really quick side note, if this was a plus sign, would you have to worry about distributing? No, I'm going to repeat that because you will have some on homework tonight. If this is a plus sign, all you do is drop your parentheses and work it out. Okay, one more time. If that's a plus sign, not a minus, if it's a plus sign, what do you do with your parentheses? Drop them. They're gone. If it's a negative, you distribute before you drop. Got it? Okay, last section is review, but I'm going to go over it. Rationalize. Do you guys remember when we rationalized our fractions? Anybody? Do you guys remember at least hearing me say rationalize?
Yes. Yeah.
Do you remember what it is?
No.
No. Okay. Number 9. 2 divided by root 7. Can I have a radical?
Oh yeah, that multiply.
Good. We multiplied top and bottom by what? Good. That's rationalizing. Why? Because we can't have a radical in the denominator. 2 times root 7 is over, without using 49, that's a pair. What is that? 7. Now, these two numbers, does anything go into 2 and 7? No. Now, these two, I have a common factor, but why am I not allowed to reduce those two? One's a radical, one is not. This is your final answer. Okay. Now, what I want to talk about is Think before you jump into the problem. Please do not work this one ahead of me, at least not yet. Okay. What is the most common thing do you think kids do when they see this? They multiply top and bottom by root 6. Is that wrong? No, but is that the easiest thing to do here? No. Look at the big picture. Is this a fraction?
Yes.
Are there radicals at the top and the bottom?
Yes.
If there's radicals at the top and the bottom, you are allowed to reduce. I'm going to repeat that. If there's radicals in the numerator and denominator, you are allowed to reduce. Does 12 and 6 reduce?
Yes.
What's 12 divided by 6? 2. So what's my final answer? Root 2. Do I need to rationalize? No. Think of it like this. Square root of 12 over 6, and 12 over 6 is 2. Square root still there. No pairs came out. Root 2 is your final answer. Got it? So, before you I'm going to rationalize and multiply top and bottom. Before you do that, assess the problem and see if you can reduce or make things a little simpler. What if you had something like this? A big square root and then 25 over 6 inside. These two are the same thing. Whether you write little square roots or one big square root, it doesn't matter. They mean the same thing. Can I reduce 25 over 6? Does it reduce? No. So I'm going to break it up like that one. Square root 25 over square root 6. Now, think of the big picture. Before you multiply top and bottom by root 6, anybody know what I should do to the numerator? Is 25 a perfect squared?
No. Yes.
And even if it wasn't, say it was 8 or 12, could you break it down?
No.
Yes. What's the square root of 25? 5. So always break down before you start to rationalize. Now what do I multiply top and bottom by? Root 6. 5 times root 6 is 5 root 6 divided by 6. Questions? We're good?
Yeah.
All right, that's it for the lesson.
Yeah.
Hey.